Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be talking about levee breaching and dam breaks. All right, what I have on the screen here is my HEC RAS. I've got a river reach sketched out down here in the geometric data editor, and it flows from 1,000 river station down to 0 river station. I have a lateral structure right here that's connected to storage area 1, and then further downstream, I have an inline structure. I'm going to be using the lateral structure to demonstrate levee breaching, and further down, I'll use the inline structure to represent dam breaks. All right, well, let's go ahead and get started here. I'm going to first talk about the lateral structure and levee, and then later move on to inline structure, which would represent a dam. All right, so if I click on lateral structure right here, you can see here's the cross section of the lateral structure. A levee is modeled as a lateral structure. The user manual mentions that the area behind the levee that represents the area to be flooded from water leaving the channel could either be a storage area, like you see here, a 2D flow area, or a river reach. Now, you'd use a storage area like I have here in the event that it's going to fill up like a lake or a pond. You'd use a 2D flow area if you have multiple different flow locations, lots of different breach areas. It has many different flow paths and different ground elevations. And then lastly, you'd probably use a river reach if the water will likely continue to flow in the downstream direction, acting as a separate 1D channel and possibly rejoining up to the main river downstream. So I went ahead and went with storage area, but just keep that in mind. Your lateral structure can connect to also a 2D flow area or a river reach to adequately model what a levee breach looks like. The user manual also mentions that you can only have one levee breach per lateral structure. So if this lateral structure here represents a levee and you want multiple breaches, then you just go ahead and have to create multiple lateral structures, probably just adjacent to each other, and then fill out the individual data associated with a breach. And you'd have to input the separate breach data for each individual breach in its own lateral structure. Once you have the main geometry here from the weir embankment, you can just see this is very basic station elevation data. Once that's in place, then what you can do is go ahead and click on this breach button up here. So in plan data, click on breach. This brings up the breach editor, the levee or lateral structure breach data dialog box. You can also access this dialog box. Let me close this here. If you go to run and then unsteady flow, which I have right here. I'm not sure how that opened up. Let me try that again. View, unsteady flow. Yeah. And then click on options. And then you're going to want to click on this option right here, levee, lateral structure breach. I already have it checked on, which means it has some data entered. So go ahead and click that and boom, you're in the same dialog box. If you want the structure to breach during the simulation, you go ahead and check on this checkbox right here. So breach this structure. It's the biggest, boldest text in the entire dialog box, so it's hard to miss. And then if you have multiple lateral structures with breach data, you can go ahead and select them from this dropdown or click the arrow up and arrow down buttons to toggle through all the different levee breach data that you have data entered for. Like I mentioned, if you have multiple breaches, you may have multiple lateral structures to represent each of those breaches. Over to the right, we have buttons for delete this breach and delete all breaches. So make sure to only click that button if you know for sure that you want to delete the breach data. And then further down below here, we have breach method and some parameter data. For breach method, we have three different options. There's user entered data, simplified physical, and physical breaching DL breach. What I currently have selected in what is default is the user entered data. Oops, click back on the breach plot tab. What that means is I'm going to be entering the data in these fields right here, which is the parameter data. If I use simplified physical, then the user enters velocity versus breach downcutting data. I'm going to go ahead and demonstrate user entered data for the levee breach, and then later in the lesson, when I get to the dam, the inline structure breach, I'm going to talk about simplified physical then, because there's a lot of overlap in the breach data dialog boxes, whether it's a levee or it's a dam. All right, so we're going to stick with levee and we're going to stick with user entered data. Now, if I click back onto this breach tab here, there's a breach plot tab, breach progression tab, and a number of other tabs along the top here. So I'm going to be talking about these over the course of the lesson as well. But I've just noticed sometimes when I click one thing, the tab focus will switch to a different tab. Anyway, what you're seeing here is data that I've already entered before the lesson began. So all these fields will be empty, but I just went ahead and said the center of the breach is going to be at station 100. So if you look at this breach here, let me close this dialog box and then move this over. This lateral structure here is the levee. It starts at river station 650, and then it goes for 200 feet down to river station 450. So if I go ahead and again open that up for lateral structure, we see station 600, 650, that's the upstream end of the lateral structure, 600, 500, and then 450, that's the downstream end of the lateral structure, 400, and then onward downstream. So what I'm thinking about doing to define a levee breach, I'm just going to put the breach right here in the middle of the levee. So it's going to be river station 550, but as far as the stationing of the inline structure goes, it's going to be halfway, so it's going to be 100. If we start the river station numbering right here at 0, and it looks like that's what this stationing is doing. Okay, so anyway, back to the breach data, and then that's why I put center stationing right here. If I change this to say 50, then automatically the image, you see this red line here, this is basically what the fully eroded, completed breach outline would look like if I'm looking at the lateral structure face on. So let me go ahead and change that back to 100. Final bottom width is 40. Again, I just made this up. It could be 0, it could be 40, it could be something different. Final bottom elevation, that's this elevation here. I typed in 207. The side slope I said was 4:1 on both sides. Weir coefficient is 2, but you can change that as well. Breach formation time, this is the duration it takes the breach to complete from its starting moment. And then further down, we have failure method. So the two options here is overtopping and piping. Overtopping is when the water goes over the top of the breach of the levee, in this case, the lateral structure. And then the erosion begins from the top down until the entire area is eroded. And then the other option is piping. What that means is a hole or something has developed in the side of the levee or the dam, and then it erodes and like kind of a, I guess, radially outward, but only to the extent of the outline drawn here. If you select piping as your failure mode, you do need to provide a couple more parameters, such as the piping coefficient and the initial piping elevation. All right, I'm going to go back to overtopping though. Trigger failure at, okay, so this represents the time, or I should say, the conditions that invoke the beginning of the levee breach or the dam breach. So there's three options. You can either go water surface elevation and then type in an elevation. So if I said 211, if the water surface got up to 211, boom, at that moment, the levee breach begins. The other option would be water surface elevation plus duration. So 211 is still the immediate water surface elevation. But if I said if the water surface elevation gets up to 209 and is there for at least 6 hours, that would also invoke the levee breach. So if that was the case, I would say 209 and then I would say 6 hours. That's how to do that. And then this is optional actually. If you select water surface elevation plus duration, you don't actually have to put a value in here for immediate inundation water surface, which the label is not particularly obvious what it means by threshold WS. But if you put your mouse cursor over the text box itself, it does give a little bit more information in the label. So for instance, right here, it reads water surface elevation for the critical threshold. And then what does this one say? Water surface elevation for immediate initiation of breach. That's actually a pretty good label right there. Last but not least, there's this accumulate duration over multiple peaks. So the user's manual didn't say anything about this checkbox, or at least I couldn't find anything, but I believe that that total duration of 6 hours could be accumulated even in like a non-consecutive time durations. So if that's true, you could check it on. That's my guess. All right, the last option here for trigger failure is set time, and this quite simply allows the user to specify the date and then the time here in military format of when the breach begins. As mentioned before, what you're seeing here is the breach plot, so you can see the outline of the breach in this red line here. See if I click the red line, it's a little bit darker, easier to see. The next tab over is breach progression. So if you click breach progression, you can see that what we have here is the speed at which the breach takes place. Now, we already specified that it's going to take 1 hour to fully breach, or 6 hours, or whatever your number is here. But as a fraction of that total time, now we have the ability to tell HEC RAS how fast it's going to breach. Now, if you don't enter any data and it's not required, then it's just going to take on this linear progression. But you can set it to linear. That's what it is. Yes. If I set it to sine wave, then click yes. It gives me the sine wave. Okay, that's cool. And then I can also enter the data myself. So I have an example. I just copied something onto my clipboard. So if I click Control V now, here's my own sine wave I just kind of came up with. So it starts slow. In the middle half, it's probably the fastest, and then it ends kind of slow. That's what is supposed to be happening here. And then also there's radio buttons up at the top that says use equal vertical and horizontal growth rate either or use the specified horizontal vertical growth rate. So if we go back to the breach plot here, then if it was equal vertical and horizontal, you can kind of just imagine the erosion taking place all at the same speed, both in the vertical and horizontal directions. If that's the case, you can use this top radio button. If it's not, then you can select the different value here. So if it was growing faster vertically than horizontal, your number would be greater than 1. And if it was eroding faster horizontally than vertically, then it would be less than 1. Okay, so that is it. We'll talk about the simplified physical tab with when we select that option here for simplified physical. That'll be a little bit later in the lesson when we talk about dam breach. But there's a tab here for parameter calculator. The purpose of this tab is used to assist the modeler to estimate the breach dimensions. So we came up with the breach dimensions right here, but it may not be obvious that these are the actual dimensions. So what we would do using this tab is sort of a separate calculator to help get us started and help figure out some of these dimensions. What we would do is type in the values here. So I'm going to go ahead and just type in some numbers. So top of dam elevation is 212. And then the side slope I'll say is 4:1 and 4:1. So once I have all that data entered and I tab off the last field, I get some suggested parameters down here based on these different engineers or scientists who came up with these different methods based on the data I provided. And also there's a few other variables here that I'm just accepting the default values for. So what I'm provided is breach bottom width in feet, the side slope, and then the breach development time. So if I want these particular values to be entered here, all I do is click the select button and then watch over here when I do, boom, all these values got filled in. So the side slope of 0.5 got entered. I could select the next one down and boom, it just updates with some of the parameter values. This allows the modeler the ability to enter lots of different input data and then get some different results when running different simulations, or rather different plans, as a way to perform sensitivity analysis and just understand what are some of the different ranges of results I can expect from this levee breach or from the dam breach. The last tab over is the breach repair. This is optional, it says. This is more likely to occur or be used when you're using a lateral structure and a levee breach. Probably not as common when using a inline structure or a dam breach. And it's also probably more common on longer simulations where there is actually a potential of repairing the breach during the simulation itself. The parameter values are pretty straightforward. It's the number of hours after the full breach to start the repair, total repair time, and then final filled in elevation. All right, well, that is it for the levee breach or the lateral structure breach into a storage area, 2D flow area, or downstream reach. Next, I want to transition over into the dam breach, or what you might call a inline structure breach. And before I do, I forgot to mention that this breach data that we're keeping track of is being saved in the plan data, not the geometry data. That way, the geometric preprocessor doesn't have to run and waste a bunch of time every time new breach data has been saved. That just saves time in the real-time forecasting process. All right, so inline structure. Here's our inline structure located between river stations 200 and 300. Once you have the basic inline structure data set right here, this is my dam, then you can go ahead and click this breach button. It says breach plan data. So click that. And here is the dam inline structure breach data dialog box. As mentioned before, you can also access this from going to the unsteady flow analysis options and then clicking on dam inline structure breach. All right, before the exercise, I had already entered this data that you're seeing here, and you're going to see a lot of overlap and similarities in this dialog box as we just saw with the lateral structure dialog box. So the checkbox here right here is to breach the structure. We can select all the other inline structures with breach data here, delete this breach, delete all breaches, and then we have some parameter data associated with the geometry or the shape and speed of the breach. So we see the red line right here. We can see it easier when I highlight it. That's what I'm putting in for the breach dimensions. So we have like the data here. This is the bottom. Oops. So here's the bottom width. I can make it less than 8. There's 8. There's a side slope of 2 to 1 and the breach coefficient. If I choose failure mode overtopping or failure mode piping, those are the same options we had before. This time we have an initial piping diameter we need to put in. And then also there's a mass wasting feature. I read that this is more likely to occur for levee breaches, but you put a hole in the dam or the levee at the beginning of the breach, and then the required data for the mass wasting feature is shown here: width, duration, and final bottom elevation. As before, we have trigger failure data. I don't have all this filled out, but we saw this with the lateral structure breach, which is the levee breach. Again, water surface elevation plus duration, or setting a time for that breach to initiate. All right, so we talked about breach plot. What I want to talk about here is select simplified physical. And when I do that for, here's the dam breach, this tab for simplified physical pops up onto the page. Now, what it's going to start you off with is a blank field right here. You're going to see a couple blank tables of data where the user needs to specify the velocity and downcutting rate, and then the velocity and the widening rate. So this basically says how fast the water is flowing and then how much erosion is going to take place. And the units here are in feet per second and feet per hour. So you can type the data in or you can just paste it in if it's on your clipboard already. But this says that at 0 feet per second and 2 feet per second, there will be no erosion. But at 3 feet per second, there will be 1 foot of erosion. That's in the vertical dimension. And then the same thing could be true for the horizontal dimensions. 7 feet per second of water will erode at 15 feet per hour. All right, so yeah, breach this structure. I think that's pretty much it for the data input on breaching both levees and dams. Everything else I've kind of already talked about with levees, breach repair, and so on. So after the simulation has ran and the breach has taken place and the data has been collected by HEC RAS, that data will of course be written to the DSS file. And a couple specific views mentioned by the user manual to check out is to click on view and then water surface profiles, as well as view and stage and flow hydrographs. These two particular views were recommended for viewing both the levee breach and dam breach when running those types of simulations.